Okay, so we're going to look at the distance between a point and a plane. They've given us a formula that is a little different, but very similar to the formula of a distance between a point and a line in 2 space. Okay? This equation, x naught, y naught, and z naught, is the point that we would be looking for. And this is the Cartesian form of our plane. The formula is essentially we take the Cartesian form and plug in our points, find the magnitude of those, all divided by the root over a squared plus b squared and c squared. So we'll do a simple example to start so we get used to the formula, and then we'll get into a very difficult example. So determine the distance between S to the plane with this equation. So they've given us everything in the actual forms that we need them. This will be our point. Remember, our distance is equal to the magnitude of A times x naught plus B times y naught plus C times z naught plus D, all over the square root of A squared plus B squared plus C squared. Make sure I didn't write that down wrong. Yeah, okay. So we have our formula. In this one, here is our A value, our B value, our C value, and this is our D. Okay? What we're going to be doing is just plugging in our x naught, y naught, and z naught into this formula and finding the magnitude of it. So D is equal to the magnitude of 8 multiplied by -1 plus, it'd be easier to just write it as -4 times 2 plus 8 times -4 plus 3, all divided by the square root of 8 squared plus -4 squared plus 8 squared again. Okay. This is just simple calculations. On top we'll have -8 minus 8 minus 32 plus 3. On the bottom we'll have the root of 64 and 64 and 16. What's that? 70, 80, 124? 144. Let's do it again. 64s gives us 8. 144? Perfect, thank you. Okay. So we have these values. On top, what do we end up with? 16, 32, 48, 45. Perfect. Now this will say -45. Oh, not 1. But because it's a magnitude, we're looking for the positive value. When we're looking for a distance, we really don't talk about distance as a negative value. It's over 12 when we root this. So our value will actually be 45 over 12. The distance between this point and this line is 45 over 12 units. Okay? That's just simply putting it to the formula. Now let's go into a very difficult type question. This will be the hardest type of question you notice here. So they've given us 2 skewed lines, and they've gone through the process of proving the skewed lines. We're just going to trust them that they are skewed. Okay? We need to find the distance between the 2 of these. Now the problem is these are in 3 space, so our skew lines, depending on what point we're at, will look like they're going to have different distances from each other. So what we're going to do is we're going to turn each skew line into parallel planes. And we're going to use the direction vector from the second line to be the other direction vector in our first plane. And we use the direction vector from the first one to be the other direction vector in our second plane. So the idea being that our plane 1 is equal to all of the info from our first line, -2, 1, 0, plus S1, -1, 1. And we're going to add to this T, 1, 1, and 2. Okay? Our plane 2 will be all of our information from line 2 plus a direction vector from line 1. 0, 1, 0 plus, we'll just line them up so on top of each other, 1, -1, 1 plus T, 1, 1, 2. The idea here is now our skew lines, and I'll Try to make a good visual of this, though I don't tend to do a good job of it. End up becoming planes that are, are now parallel from each other. Because we've used the same direction vector in each of them, we now have direction vectors that are parallel to each other. So now the distance between them is consistent. Okay? Once we have that, all we need to do is turn one of the planes, let's say the first one, into its Cartesian form of ax plus by plus cz plus d. And when we have that, our point to that plane will just be the point on the other plane. So what we'll do is we'll take the first plane and put it into the Cartesian form by finding the cross product between our direction vector m and n, we'll call them. Okay? So the direction vectors are actually the same in both, so we've called them m cross n, which means direction vector m is 1, -1, and 1, which is a1, a2, a3. And direction vector n is 1, 1, 2, which is b1, b2, b3. Okay. When we find the cross products of these, that's a2 times a3 is -2, subtract b2 times a3, 1. That's our x value. Our y value would be a3 times b1, which is 1, subtract b3 times a1, which is 2. And finally, a1 times b2 is 1, subtract b1 times a2, which is -1, which is the same as adding the value of 1. So that gives us our x, y, and z, which gives us -3, -1, and 2. These become the a, b, and c values in our Cartesian form. So we have -3x minus 1y plus 2z, and we're missing our d value. How can we go about finding our d value in this question? Plug in a point. Exactly. We have 2 points here, and we've actually found the normal to because they're parallel, both of these. Okay? Both of our, sorry, I meant to underline these. Both of our direction vectors are the same, so we have the normal from both. So we just have to keep in order what we're doing. If I plug in this point, that means I'm finding the Cartesian form of plane 1. If I plug this point in at this step, then I'm finding the Cartesian form of plane 2. Let's stick with 1. -2, 1, and 0. That'll be the point we'll plug in. Is that right? -1, 2, 0? I don't remember. I'll look up. -2, 1, 0. -2, 1, and 0. So this will be our x, y, and our z, which we'll plug into here to find what our d value is. -3 times -2 minus 1 times 1 plus 2 times 0 plus d is equal to 0, which will give us 6 plus 1 plus 0 plus d is equal to 0. Oh, thank you. Thank you. -1, 0. Good. Gives us 5. D is a value of -5. So our Cartesian form is now -3x minus y plus 2z minus 5 equals 0. Now remember, if that's our Cartesian form, and that was plane 1, we're now finding the distance between plane 1 and the other point. So the point on plane 2, which is 0, 1, 0. Okay? So our p in this equation, when we go to put in our formula, is 0, 1, 0. Now we can use that formula once we've set this all up properly. We can use our distance formula. That is the magnitude of a x naught, this being our x naught, plus b y naught, because I said so, c z naught, plus d. The magnitude of all of this over the root of a squared plus b squared plus c squared. Okay? And this is where it becomes strictly just calculations, very similar to our last example. So we have -3 times 0 minus +1, which is -1, plus 2 times 0 plus, -5, find the magnitude of that over the root of 3 squared. I'm just going to plug the values in. So 9, 1, and 4, which will give us 0, negative 6, 6. Because it's a magnitude of negative 6, it'll end up being the value of 6 over the root of 14. So we have the distance between the two skew lines is 6 over root 14 units. Okay? So the toughest part about this is the very beginning where we have to set them up as planes. Once we've set up all of that, it's just plugging into our formula.